Ever wondered what secrets the sun hides within its fiery heart? Today, we're diving deep into the heart of our solar system, the sun. But this is not your typical science class. We're going beyond the basics, delving into the lesser-known facts and unraveling the mysteries of our star. From its complex composition to its puzzling core, from its twisted magnetic fields to its scorching corona, we're exploring it all. Prepare to journey into the heart of our solar system. The sun doesn't just sit there in the sky, it's on a cosmic journey. Imagine an enormous star, our sun, twirling like a top and waltzing around the center of our home galaxy, the Milky Way. But it doesn't go alone. It drags the entire solar system along with it, planets, asteroids, comets and all. Fascinating, isn't it? This cosmic waltz is no swift twirl. It's a slow, grand dance that takes roughly 225 million years to complete one spin around the Milky Way's center. That's what we call a galactic year. And here's a mind-blowing fact. The last time our sun was in its current position, dinosaurs were just beginning to roam the Earth. So the next time you bask in the sunlight, remember, we're not just rotating, we're also hurtling through space. So, every day, we're traveling millions of miles without even knowing it. When we think of the sun's composition, hydrogen and helium come to mind, but there's more to it. Indeed, hydrogen and helium make up a whopping 98% of the sun's composition. But what about the other 2%? Well, that's where things get a bit heavier, literally. The sun also contains heavier elements such as oxygen, carbon, neon, and even iron. But where do these elements come from? They're not just products of nuclear fusion, they're the remnants of ancient stars that have lived and died long before our sun was even a twinkle in the galaxy's eye. These stars exploded in spectacular supernovae, scattering their enriched guts across the cosmos. Over time, these scattered elements coalesced to form new stars, like our sun, bringing with them a rich chemical legacy. So the sun is a cosmic recycling center, using the remains of dead stars. Ever heard of solar flares and sunspots? They are the results of the sun's twisted magnetic fields. Now you might think of a magnetic field as a simple north-south affair, much like the Earth's. But the sun plays by a different set of rules. Its magnetic field is not a straightforward dipole. Instead, it's a complex, twisted mess, an entangled web of magnetic lines. This is due to something called differential rotation. Simply put, different parts of the sun rotate at different speeds. This causes the magnetic field lines to twist and tangle, creating regions of intense magnetic activity. These regions are where the drama happens. Sunspots, those dark patches you see on the sun's surface, are areas of intense magnetic activity. And solar flares? They are massive bursts of energy caused by the reconnection of these tangled magnetic field lines. So the sun's magnetic field is a chaotic masterpiece. The sun not only shines, but it also sings. Yes, you heard it right. Our very own star vibrates and oscillates much like a ringing bell. These oscillations are not random, but rather rhythmic pulsations that breathe life into the sun's outer layers. But how do we know this? Well, that's where the fascinating field of helioseismology comes in. Just as seismologists study earthquakes to learn about Earth's interior, helioseismologists monitor the sun's oscillations to unravel its inner structure. These oscillations, traveling as sound waves, give us clues about the sun's core conditions and composition. The wave's speed, amplitude, and direction all provide valuable data, offering us a glimpse into the unseen heart of our star. It's kind of like using the sun's own voice to reveal its deepest secrets. So next time you look up at the sun, remember that it's more than just a ball of fire. Thanks to helioseismology, we have a way to listen to the sun's song. The core of the sun is where the magic happens. This place, the heart of our star, is a realm of extremes, where the laws of physics dance in the most spectacular and mind-boggling ways. Picture this, a sphere of plasma, over 100 times denser than water, and with temperatures soaring to 15 million degrees Celsius. It's here, in this tumultuous cauldron, where hydrogen atoms are squeezed together to form helium in a process known as nuclear fusion, releasing a tremendous amount of energy. Now here's a surprising fact. The sun's core rotates faster than its surface. Yes, you heard it right. This counterintuitive phenomenon was confirmed by observations of neutrinos, nearly massless particles that zip straight from the core to us. It's a delightful twist in our understanding of our star, proving yet again that the sun is full of surprises. The sun's core is indeed a place of extreme conditions and surprises. The sun's corona is a mystery that has puzzled scientists for decades. This enigma revolves around an unexpected twist. The corona, the sun's outermost layer, is far hotter than its surface. We're talking millions of degrees Celsius, compared to a mere 5,000 degrees on the surface. Now, you might ask, how can the atmosphere of a fire be hotter than the fire itself? Indeed, it defies logic, and yet it's a fact confirmed by countless observations. So, what's the explanation? Well, that's where the mystery deepens. Scientists have proposed many theories, one of them being the concept of nanoflares, tiny but powerful eruptions on the sun's surface that inject heat into the corona. However, none of these theories have been definitively proven. Research continues, with solar probes and telescopes peering into the heart of our star, seeking answers. The solar corona remains one of the sun's most intriguing mysteries. The sun has always been a source of fascination, even in ancient times. It was more than just a celestial body. It was a symbol of power, life, and wisdom. In ancient Egypt, the sun god Ra was worshipped as the king of all gods, while the Greek god Helios was believed to ride his chariot across the sky each day, bringing light to the world. In the Americas, the Mayans and Aztecs built elaborate temples and observatories to track the sun's path across the sky, using its movements to create incredibly accurate calendars. The Chinese, on the other hand, revered solar eclipses as significant events, recording them meticulously in their royal observatories. The sun was not just a source of light and warmth. It was a celestial clock, a divine entity, and a cosmic mystery. It shaped cultures, structured societies, and inspired myths that have endured for millennia. Ancient civilizations were more connected to the sun than we might think. Our sun won't shine forever. It has a destiny. As we peer into the cosmic crystal ball, we see the sun's life story unfolding. In about 5 billion years, our ever-glowing star will bloat into a red giant. Its outer layers will expand, swallowing Mercury and Venus, and possibly even reaching Earth. This phase will mark the end of the sun's hydrogen-burning days, but that won't be the curtain call. Over the next billion years, the sun will shed its outer layers, revealing a hot, dense core. This stellar relic, known as a white dwarf, will be all that remains of our once vibrant star. Its light will slowly dim over billions of years until it becomes a black dwarf, a cold, dark and silent celestial body. But fear not, this is not an immediate concern for us or our planet. It's a cosmic eventuality, a part of the universe's grand design. The sun's fate is a reminder of the cosmic cycles of life and death. And that's a wrap on the secrets of the sun. We're grateful you've joined us on this stellar journey. Don't forget to subscribe for more cosmic revelations. Join us next time as we explore more mysteries of the universe. Until then, keep looking up.